an array is like a variable, so we've been using variables a lot. An array is like a variable, but you can store a large number of values in an array. So you can store like a group of values. So I'm just going to put that an array is like a variable, but you can store groups of data. So you can store groups of data. Show you an example. So let's say that we have an array so we're going to declare it as an integer. So basically we're going to have an array of integers, and let's call our array test. So the name of the array is going to be test, and then we're going to do some square brackets, and what goes inside the square brackets is a number representing the size of your array. So let me just specify these. So this int is the data type of the array, and this can be any data type. So you could have an array of doubles, an array of strings, a character array. So this can be any data type. And then this is the name of the array. And then this is the size of the array, but this is specifically called the size declarator. And so basically what this is saying is that we have an array with 5 elements, because the array is, the size declarator is 5. So we have an array of 5 elements of integer data types. And so the way this would look, let's just draw an array. So we have an array with 5 elements, so let's split this up. 3, yeah, so that's 5. So let's say that this is our array of 5 elements. Each of these elements can hold an integer, so just specify that. So we want to look at how these are numbered. So in C++, and this is different for some languages, but in C++, the first element of your array is 0. And so the numbering starts at 0, and then we have element 1, and this is 2, element 3, and element 4. And we're going to see, so notice how the element numbering goes to basically n minus the number of, so let's say that n is equal to 5, so n is the number of elements in the array. So your actual numbering, it goes to up to n minus 1, because the numbering starts at 0. And this is different for some languages. So like I know in MATLAB, the numbering starts at 1. So if you've seen the numbering start at 1 in a different language, just remember that C++ starts at 0. This can cause confusing errors if you're thinking it starts at 1 and it starts at 0. The other thing I want to point out before we move on is the size declarator has to either be a constant, integer, or literal greater than 0. So when we specify this size, so right here we're using literal, right? So we're putting 5 in, so that's an integer literal. This has to be either a literal or a constant integer. So basically, if you want to put a variable in there, it has to be declared as a constant. And we're going to see some examples of that. And then the other thing, the size of the array. So this particular array has 5 elements because we declared it to have a size of 5, we declared it to have 5 elements, but the size of the array, like the number of bytes it's going to actually use, is the number of elements. So number of elements multiplied by the size of each element. So for instance, with this particular array, since each element basically has an integer, the size of, so an integer takes up 4 bytes. So that means that the size of this particular array is going to be 5, which is the number of elements, multiplied by the number of bytes that each element occupies. And this 4 is assuming that each integer is using 4 bytes. So assuming each integer uses 4 bytes. And so that means this array is going to take up 20 bytes. So in other words, when we declare this array, we're going to reserve 20 bytes in memory for this array. And this can be important depending on like the size of your array, because as you can imagine, these can get pretty big, and also the amount of available memory you have on your computer. So you can run into problems with arrays being too large, depending on what you're doing. And so I already mentioned this, arrays can be any data type. So we could have, like, let's say we have a bunch of temperatures, so we could do float, and then let's say that, so the data type is float, and then let's say the name of our array is temperature. This has 100 elements. We could do characters, so character, and let's say this is letters, and then 25. So we can do this with we can create an array with any data type, which is pretty useful if you think about the different things you could do with this. So let's say we have a list with a bunch of names. You could have an array with strings and have all those names in basically one variable, like in the array variable names. So arrays are pretty convenient when you're dealing with groups of data, which we deal with groups of data all the time. Like you think about spreadsheets. If we have everything, like everything we have in one column or one row might be a group of data that we might want to just have in an array. And rather than having like say we have an array with 100 names, what we've been doing so far, you would have to have 100 variables, one for each name. So this arrays are a pretty convenient way to store things. So now we have our array, we know how we can declare arrays, but now how do we access the data in these arrays? So how do we access array elements? So basically we've already seen, like, and I'll redraw it, but with the example I gave above, so we've already seen that each element is numbered with a specific subscript. So start at 0, 1, 2, 3, 4. So this would be for the 5 element array. So it starts at 0 and ends at n minus 1, where n is the length of the array. So then let's say that we want to access the first element, so that would be the 0 element. Let's say we want to store an integer to this element. And I'm going to write down, so this array was int test5. So let's say we're storing test scores to this array, and we want to store a value to the first element. So we just do the name of the array, so tests, and then inside these brackets we put the subscript, or the number of the element we want to access, and then we just say that that's equal to, let's say we want to store 79 to that element. So now what we're going to have is, if we redraw this array, this is 0, 1, 2, 3, 4. Now we have 79 stored in the first element of this array. And let's say we want to store something to the second element. We just do tests, and we do the subscript for the element that we want to store the value to. And let's say this one's 80. So then we have 80 in the first element, and so on. So basically we can fill up this array by assigning values to each element. And then let's say we want to print out these values to the screen. We can access the array element the same way we stored something to it, by just doing, say, cout. And let's say we want to display what we have stored in the first element, this would just be cout tests 0. And we can read stuff in and store it to the array. A test, let's say we want to get a test value from the user and store it to the third element in the array, which has a subscript of 2. We would just do cin tests and then 2. So then the cin is going to pause. It's going to ask the user for a number. Let's say the user enters 90. It's going to store 90 to the third element of the array. We can also add array elements together and store them in another element. So for instance, we could do, say, tests. So if we do tests 4, this is going to access this last element in the array. And then we could say something like tests 0 plus tests 1. So if we do test 0 plus test 1, basically we can access, like, I like to think of these array elements as we basically use them the same way we've been using variables, only now instead of reading out a variable or reading something in and storing it to a variable, we're reading out, say, an array element, or we're reading something in and storing it to the array element. So now let's say that this is now int numbers. Let's do 5 again. Let's say that we want to store 99 to every element in this array. So what we want, let me draw the array. And when you're working with arrays, especially when you're writing programs that have arrays, it's really helpful to draw, like physically draw the array and then write down what's being stored in it, because then you can get a quick visual of what you're doing, and that's going to be a lot more straightforward than trying to just think about it, especially when we talk about two-dimensional arrays a little bit later. But let's say that we have this array and we want to store 99 in every one of these elements. So let's say, like, and there's a lot of reasons why we might want to do this. We might declare an array, and for some reason we want the same value in every element until it's changed later. So this is something that you might want to do. But the way we can do this, if we look at these array elements, so we have 0, 1, 2, 3, 4, since these are in order, like 0, 1, 2, 3, 4, we can step through the array with a loop. And so we can have 4, and we know how many array elements we have, so we're going to use a for loop. So we could do 4, and let's just say int count is equal to, and this is really important, you want to start at 0. So this is where people make a really common error. They'll start their for loop at 1, thinking that the array starts at 1, and it really starts at 0. And I've made this mistake before just because I've done a lot of programming in MATLAB, and MATLAB starts at 1. So depending on what you're doing, it can be easy to make this error. And then we want to go, so if we're stepping through the array, we want to go to 1, 2, 3, 4. So we want it to get to 4, but not 5. So this means the count needs to be less than 5, and then we're just going to increment it. And then what we're going to do, so we're storing 99 to each array element, so we can just do number count is equal to 99. So then what this is going to do is, so when we come in here, we have count is equal to 0, count less than 5. So right now we have number, so for the first loop, we have number 0 is equal to 99. So what that's going to do is store 99 to the first element. Second time through, we have number, and then this is 1 is equal to 99. So then it's going to store 99 to the second element, and so on until we get to count equal to 4. And one thing I want to mention, I forgot to mention this when I drew the first array, is these array elements are stored in memory in sequential locations. So when your array is declared, it's going to store, so it's going to reserve, let's say that we have a memory location. Let's just say it's 23, just to make something up. So let's say that our first element is in memory location 23. That's going to be 4 bytes. And then this is going to put each successive element in the next memory location. If these are memory locations, so specify that that's what this is. This is going to be 23, 24, 25, 26, 27, and then there's more memory locations out here outside of the array. So I just wanted to point that out. I meant to mention that when I first showed the array structure. So I also mentioned that I would show you, so the arrays we've declared so far, we've used a integer literal. So we can also use a constant integer for our array size. So we could do something like constant integer, and then since this is a constant, I'm going to make it all uppercase, so size equals 5. And then we can use this to declare our array. So we could then do int number and then size for the size declarator. And then we can also declare our arrays with this with a constant integer instead of putting a literal for the size. Your array size has to be either a literal or an integer constant. And the reason why is because the compiler needs to know how much memory to reserve for the array. And we're going to talk later about how to, because you might be thinking, well, we might not know the size. So you can use dynamic memory allocation if you don't know the size, but we're not going to get to that until a little bit later.